Hello guys, and welcome to today's webinar from Royal Cyber. Before we begin, let me introduce myself. My name is Ammar Nadeem and I am a business development executive at Royal Cyber. I've been with the company for more than 2 years, and we like to do interactive webinars for our customers and client base. For today's topic, we're going to be discussing how to do multi-domain SSO for WebSphere Portal with IBM Security Access Manager. Now, before we start this, just want to give you a brief introduction on the company. Basically, Royal Cyber is an IT consultant industry. It's been in the IT consultant industry for more than 12 years, and we offer full lifecycle technical support on both IBM and Microsoft products. Royal Cyber Incorporated has more than 500 IT consultants in over 9 locations worldwide. We also provide world-class customer experience and exceptional technical support 24/7 to support our customer. Now, we have offices located all over the globe. You're free to contact at any office within your region. Today we have a very special guest today. He is our technology consultant for Royal Cyber. Let me introduce you to Mr. Awais Sheikh. He's basically going to be presenting the webinar. He has an IT professional for over 5 years experience in system security, software engineering, computer networks, operating systems, and database. So without any further ado, let me introduce you to Mr. Awais Sheikh, and he can take over the webinar.
Thank you, Ammar, for the introduction. Hello everyone, this is Awais Sheikh, and as you know that today's webinar is about a multi-domain single sign-on. And before getting to the topic, let me just first give you the baseline of this product, that what this product does and why do we need it. IBM Security Access Manager is basically a product that provides threat-aware access management for web, mobile, and cloud applications. It offers a centralized policy-based user authentication and authorization system to guard against persistent security threats and provide maximum application level protection without modifying the application themselves. So it can enable IT organizations to centrally monitor and control user access to a wide array of applications, from traditional web to a newer mobile and cloud-based applications. And as we all know that most of the enterprises are beginning to open up their IT systems to a larger number of consumers, employees, partners using new business channels like mobile and cloud. So there's a growing need to have an end-to-end security infrastructure in place that can enforce consistent security policies regardless of the channel or the device that is being used. So in this case, the IBM Security Access Manager appliance enables organizations to confidently create users access policies that address the unique security concerns of their business. It's an easy to use tool, like a graphical policy editor that allows users to author context-aware authorization decisions in a natural language format. And then there is a risk-based access feature that is designed to determine and score risk levels using user attributes and real-time context. So access policies can be written to support multi-factor authentication as well, that require user to prove their identities in more than one way. It also integrates with the broad third-party security ecosystems for strong authentication and biometric support. All of these features combine to provide overall improvements in identity assurance. The appliance also offers an even greater converged value by providing embedded web content threat protection that is powered by IBM's X-Force. It offers comprehensive converged for the OISP top 10 application risks, including common attack vectors like cross-site scripting and SQL injection. It also has the ability to enhance enterprise-wide security intelligence and compliance by integrating with IBM Security QRadar intelligence platform, providing insights into how users access information hosted on premise or in the cloud. It can also enable you to integrate with other third-party security information and event management tools. So the question comes that why do we need Security Access Manager when applications in an enterprise already have their own mechanisms to authenticate users and their own security infrastructures. So that is explainable in a way that there are several cases in which organizations has multiple online internet services and other in-house applications running on server for multiple vendors. And both internal and external business partners need to access those applications. Such organizations also need an audit that who is accessing these applications and what on these applications are being accessed. And then in this specific case, they also want to enable single sign-on to them. Now, how does IBM address to this scenario? With Security Access Manager for web, it provides an identity firewall for web access management. It provides like web single sign-on to a wide variety of backend application servers, such as there can be WebSphere application servers, .NET applications, Oracle-based applications, SAP, and etc. From multi-vendors. So it provides centralized login and session management for the users accessing any applications running on any application servers protected by IBM Security Access Manager. And there you can also have multiple type of strong login IDs, including RSA, secure ID, and digital certificates, and other out-of-the-box solutions. So here in this picture you can see that how the environment looks before bringing ISAM into the action, and what positive things it can add after implementation. Like before ISAM, there always remains a password memorizing issues for several application accounts, which can be overcome with ISAM. And before ISAM, every application would need an individual administrator but with ISAM there will be a unified administration. So similarly, the security tasks can also be overcome by each separate application itself. With ISAM, security is just centralized. There will be a centralized IT management task having common security standards for all enterprise applications. So this application, this product has different components. As you can see, there are multiple components it contains. It supports multiple user registries like Security Directory Server, Active Directory, Lotus Domino, Novely Directory, Someone Directory, etc. And ISAM basically requires these registries to manage the database of its users and groups. Then it comes to the policy server, which is the master authorization database of secure domain and plays a key role in the management of access control, authentication, and authorization. In the security access management environment, it has only one policy server and one user registry. The policy server sets the security policy. The security policy is stored in the master authentication database. Then there is a Security Access Manager Java runtime environment that must be installed and configured on a server that will use ISAM, because it has all supporting files and libraries that an application in a secure domain can use. Then there is another policy enforcer, also known as WebSeal. This basically acts as a reverse proxy between the browser and the web server. WebSeal is a high-performance multi-threaded reverse web proxy that applies the security policies to the web-based resources. It looks like a web server to the clients connecting from the internet. Then there is authorization server, which basically is an optional component to offload the burden of policy server. And Web Portal Manager is another component, which is a graphical user interface of ISAM to provide the administration. So let's come to the user registries. This application has an embedded LDAPS server, which you can configure the security access management runtime environment. You can choose to use an external user registry for storing the metadata, or use the same embedded user registry. This same user registry can optionally be used to store the associated user data for the users. Security Directory Server is a proxy server there is also a proxy server in security directory server, basically, which is a special type of directory server that sits in front of multiple distributed directories. What you can gain with this LDAP proxy, with it there will be obviously an high availability, failover and load balancing concepts. A huge data can be distributed among those directories, and you can have scalability behind these behind the ISAM within your registries. And yes, it can also do the request rerouting for the performance improvement. Basically, the features this LDAP server provides is that it is IBM's its own. It has a reliable IBM DB2 Universal Database Engine that offers massive scalability to hundreds or millions of entries, as well as groups with the hundreds of thousands of members. But it provides robust application capabilities for both master and subordinate application gateway, cascaded and peer-to-peer application with up to dozens of master servers. And it also eases the management and usability with the web admin tool. For example, if you have dynamic or nested groups or anything like that, or you want to search among the millions of entries, then the web administration tool is just meant for that. The main thing is, if a person uses this security directory server for behind the IBM Security Access Manager, the main benefit would be that it has a tight integration with IBM all operating systems, like WebSphere middleware, IBM Tivoli, Identity Manager, and all other security products. And not only this, it also provides industry certified openness and dynamic extensible schema for broad and flexible application support. There is another feature in this directory server, which is called pass-through authentication. This is a mechanism that actually helps a client to build a directory server or a proxy server even if the user registry or user credentials are not available locally. For a directory server, the user registry or user credential might not be present in the DIT, directory information tree of ISAM. Whereas in a proxy server, the user registry or user credentials might not present on the proxy backend servers. So in such cases, the server attempts to verify credentials from an external directory server, that is a pass-through authentication on behalf of the client. The credential here is the password stored in the user password attribute. So to use this pass-through authentication in a distributed environment, administrator must set the proxy PTA enabled. This is an environment variable, and this environment variable must be set on the proxy backend servers with the pass-through authentication interface configured. And administrator must restart the proxy backend servers after setting the variable. Or you can also specify the server per user for pass-through authentication, as shown in the example here. The only configuration that is required is to set two attributes. The one is PTA server info and the other is PTA server ID of any user in that registry. So when looking up for the credential of a particular user, server will follow the information provided in these attributes. So this LDAP server also supports secure connections for pass-through authentication. To configure pass-through authentication over SSL, you must ensure that certain requirements are met. Like there's a parameter IBMS LDAP PTA URL for pass-through authentication that must be set to like LDAP S URL in the following format. Like both external pass-through authentication server and IBM Security Directory server must run in secure mode, though the pass-through authentication configuration in IBM Security Directory server does not require any extra key store file. It depends on the same key store file that is used by the main server component. So IBM Security Directory server must be configured for SSL communication for pass-through authentication over SSL. And the external pass-through authentication server must communicate with LDAP clients with the same key store file and the key store password that is used by IBM Security Directory server. And in what happens in a distributed environment, in the proxy server routes the credential information to the backend server for pass-through authentication. And a simple pass-through authentication interface is considered when the distinguished name of a user entries is identical on let's say server X and server Y. If no attribute mapping is specified, then the DN of the entries is authenticating server. It must be mirrored on the DN of the entries of pass-through authentication server. However, the user entries are not required to be identical on the authentication server or pass-through authentication server. So a directory hierarchy layout might be different on both servers. A user entry like for example, if I say cn equals to Tom Brown and O sample on server X, it can be mapped to some other DN on server Y. So in such situations, it must be identify that an attribute with a unique value in the entries on server X and server Y. For example, UID. We can use this attribute with a unique value from security directory server to map with an attribute in the pass-through server. Then you can use the map information to query the pass-through server to retrieve the required DN. Another solution that comes with ISAM is the LDAPS sync. This solution basically provides both migration and synchronization services from one or more source systems like Sun1 directory or Active Directory to a target LDAP directory server. This solution has been created with the security directory server as the target. So this basically solution is designed to migrate and synchronize person, group, and all those entries between one or more source directories to a single target directory. And in addition, container classes like organizational unit and DC object can also be handled, so that a subtree in the source directory will be mirrored in the target. So one thing that is to be noted here, that passwords are not handled by this migration or synchronization solution. Instead, there are other options to explore this. Like if the source system will continue to exist, for example, any other directory like Active Directory, then you can use the pass-through authentication feature that we discussed earlier to continue using the source directory for user authentication. And furthermore, that pass-through authentication can be configured to migrate password on demand as user authenticate. There's another product, Tivoli Directory Integrator, that provides those sync plugins. So this solution creates a set of log files. There's a folder. When you configure this solution with ISAM, you will see a log file, maybe named as, I don't remember it exactly, maybe it is group members missing or something like that, or another log files, just to keep the log and record of what is being synced and how, if there is any error, then you can look up into it. So this was the just basic overview of the product, that what we have here and all of its components. Now let's come to the actual topic, that is the authentication mechanism, before talking about the multi-domain authentication. Authentication is basically, as this is the process of identifying an individual process or identity that is attempting to log into a secure domain. So WebSphere provides several built-in authentication methods by default. The result of authentication to create user credential, which has information about users, group membership, and other attribute information. So WebSphere then makes the authorization decision. There are common authentication mechanisms offered by Security Access Manager. As you can see that basic authentication, form-based authentication, token authentication, and others. So let's take a look on each one of these individually. The first one is the basic authentication. So this is the standard method which is commonly used around the industry for providing a username and password. Basic authentication can be implemented over HTTP or HTTPS secured, and it has a header that is sent with every request, closing all browsers windows by the only way to stop the browser from sending user IDs and password in the header. So by default, WebSphere is configured for basic authentication over HTTPS. So during basic authentication, the user ID and password are inserted into the header of of HTTP request, and then the browser sends this information with every request to the same server. So when WebSeal send a basic authentication challenge to a browser, the browser opens up a dialog, as you can see in the image here, requesting or challenging a user to enter its user ID and password. And after the user entered his credentials, the browser sends its original request again, this time with the user ID and password included in the BA header of the HTTP request. So WebSeal extracts this information from the header and uses it to verify the identity of the user. Within the WebSeal, this is basically the process of basic authentication. As you can see in the chart, that if no basic authentication is received with the initial user, WebSeal sends an authentication challenge. The authentication challenge prompts the browser to display a login box, which you see in the earlier screen. So after the login is complete, the original request is resent with a basic authentication header. And after WebSeal receives a request with a basic authentication header, it searches for a match in the cache. This is the first request, and then there is no match. WebSeal authenticates the user and builds a user credential for the information in the basic header. So the credential authorizes the user and then stores the information in the cache. WebSeal also associates the user credential with the session key. That session key can be used as an SSL session ID or an HTTP cookie. So basic authentication is relatively easy. Most administrators choose another method. Basic authentication has an unsophisticated user interface and is set by the browser, so the session remains open unless you close all the browsers. When the basic authentication or forms authentication is enabled over HTTP, the user ID and passwords are transferred over the network in clear text format. To make sure that the user ID and password remain private, you should use HTTPS. The next method was the form-based authentication, and in the form-based authentication is just an alternative to the basic authentication. It provides a custom HTML page instead of a standard login prompt. Browser does not store, in this case browser does not store the user name or password information in the cache. So the forms authentication, it provides more flexible user interface than the basic authentication. For example, with the forms authentication, you can provide customized error messages to user when the authentication fails, or include images in the login form as well. This method is widely used because of it is more flexible, and it uses cookies to maintain the state of a user. So after the cookie is sent to the browser will send that cookie along with each subsequent request that WebSeal server. The cookie contains a single large random integer which WebSeal ensures is not already in the cache, and then the user credential is associated with the number in the cache. So WebSeal cookies has a very short lifetime to minimize the risk of cookie being stolen and used as the access to the server. It only uses to grant access to the same WebSeal server. So the cookie only contains a link to the credential, not the credential itself. The next method that it has is the token authentication. So Security Access Manager provides a built-in two-factor authentication method, an X token authentication, that is a client of a RSA secure ID authentication. And it is written against the RSA authentication API. So WebSeal provides an RSA authentication client functions, and it is certified with the RSA secure ID as well. So the token, another thing is the token authentication module, and this can be either a hardware or software, as you know. Hardware tokens are in the form factor of a key fob or pad. So authenticators are responsible for generating the new token codes, and each authenticator requires a secret key or seed value that is used to generate its sequence of token codes. So without the original seed value, it is believed to be computationally infeasible for an attacker to determine the sequence of token codes. So when the user logs in, the current pseudo random number is usually combined with the PIN, and this is the second factor of authentication, and it improves security. User's authenticator could be stolen by an attacker, but without also knowing the authenticator's PIN, the attacker would not be able to authenticate as the user. Thus, the security of the system is not compromised unless both forms of authentication can be broken simultaneously. The other one is the SPNEGO protocol and Kerberos authentication. With WebSeal, it supports obviously a SPNEGO simple, which is a simple and protected GSS API negotiation mechanism protocol, and Kerberos authentication as well. So for the use with Windows clients to achieve Windows desktop single sign-on, the SPNEGO protocol allows for negotiation between the client browser and the server regarding the authentication mechanism to use. The client identity presented by the browser can be verified by WebSeal using Kerberos authentication mechanism, and WebSeal supports for Kerberos authentication as well, and it has been implemented specifically to support a Windows desktop single sign-on solution. So this solution requires that the WebSeal server should be configured into an Active Directory domain, and that the WebSeal should be able to access Kerberos key distribution center. And in distribution, the Internet Explorer client must be configured to use the SPNEGO protocol and Kerberos authentication when contacting WebSeal. Another thing is the LTPA authentication, which is another method of authenticating with the with IBM Security Access Manager. So when a user is unauthenticated and it makes a request to a WebSeal protected resource, so the WebSeal, what would WebSeal do? It will first determine whether an LTPA token cookie is available or not. If an LTPA cookie is available, it will validate the contents of the cookie, and if successful, create a new session based on the username and expiry time contained within the cookie. If no LTPA, lightweight third-party authentication cookie is available, the WebSeal will continue to authenticate the user using the other configured authentication mechanisms. So that's how it works. Once the authentication operation has been completed, a new LTPA token will be inserted into the HTTP response and passed back to the client for consumption by another LTPA enabled authentication servers. So with this LTPA cookie, which serves as an authentication token for WebSphere or any other application, contains the user identity, key and token data, buffer length and expiration information, and etc. So this information is encrypted in using a password protected secret key that is shared between the WebSeal and other LTPA enabled servers. So here's the small process, a brief process with the integration of IBM WebSphere Portal using LTPA keys. So the process works in a way that if when the user requests a resource protected by WebSeal, user is challenged by WebSeal for credentials, and the user supplies them. So the WebSeal basically authenticates the user by communicating with its user registry. It also determines whether the user is authorized to open the requested URL or not. So upon successful authentication of the user, WebSeal creates the LTPA token cookie for the user session. So the request is passed to the IBM HTTP server using the junction that is configured for it. So the junction from WebSeal to IBM HTTP server is configured to pass the information in IV user and IV groups header, and the LTPA token that was created in step 2, as you can see, it will be passed in the HTTP header. So the request is then forwarded to an appropriate WebSphere application server or any clone as determined by the application server plugin. So in the final step, the WebSphere application server, if the TIE that is Trust Association Interceptor is not enabled, an application server gets the LTPA token in the header. Application server only creates the session cookie of this user and assumes that this user has been authenticated. So WebSphere Portal searches LDAP for the group information, gets the resource mapping from the database, and then displays the portal page. So that's how it worked with the WebSphere Portal. This is the general authentication mechanism of a site visitor that is visiting any protected resource that is behind the WebSeal. So in this you can see that as the first step, the user requests from a web browser to the authentication server, and the authentication server is basically the WebSeal. So the authentication server challenges the user for their assigned identity, and user reply with a supplied with the supplied credentials, whatever user ID and password they have. Then the WebSphere server will verify the credentials with the available user registry that it has configured or integrated behind ISAM. And upon authentication, it also creates a cookie for future use. Then the authentication server forwards the request to the application server. Application server verifies the credentials by calling the trust association interceptor. This is an optional step. This architecture will work if TIE is not even configured. So the application server look up for the user in the registry, and after successful verification, it generates the LTPA token to identify the user in third-party application. And after completion of all these steps successfully, the authorization server gives the output to the user. Let's come to the actual topic of this webinar, that is single sign-on on multiple or multi-domain. Security Access Manager for web is basically a security resource management support that supports cross-domain single sign-on and e-community single sign-on. There are two methods to configure a single sign-on across different domains or different DNS names. Both of these single sign-on solutions imply authentication tokens that is described the user identity to the destination server. But the construction of these tokens by the initial server is called token creation. So the decoding and the use of those tokens by the destination server is called token consumption. And to integrate non-WebSphere servers into the cross-domain single sign-on or e-community single sign-on, you can also write custom modules that can create and consume tokens. And there's also a way to customize the cross-domain mapping framework to enhance the cross-domain single sign-on and e-community single sign-on environments using the WebSphere servers. So let's talk about the e-community single sign-on first. E-community single sign-on is the implementation of a cross-domain authentication in a security access manager environment. The goal of this solution is to allow users to access resources from multiple servers in multiple domains without re-authentication. And e-community is a group of distinct domains. Like the domains can be only DNS or real different domains that participate in a business relationship. So these participating domains can be configured as part of one business and perhaps using different DNS names for geographical reasons, or as in separate business with shared relationship. For example, company headquarters, a life insurance company, and financial management company, or else, etc. So in either scenarios, there is always one domain that is designated as the home or the owner domain. In this case, participating businesses, the home domain owns the business agreements and that govern the e-community. Whatever, in both scenarios, authentication information about the users who participate in the e-community, including the usernames and passwords used for the authentication, is maintained in the home domain. So this arrangement allows a single point of reference for administration issues, such as help desk calls within the e-community that all refer to the home domain. This is the single sign-on model for e-community. With this model, you can get the basic idea behind e-community single sign-on. Like in an environment where there are multiple domains, and obviously each one of those domains will have their own registries and enterprise applications that is used by the internal and external users, and now they tend to have a single sign-on across these domains, so that the user of each domain can have an access to resources of another domain without having the authentication or with using any other medium to get the access. This environment will definitely need to configure and designate the master authentication server and make the user authenticate to this master authentication server for the first time only when they enter the e-community domain, and then when the users will try to access any resource from outside the domain, they will not be asked to re-authenticate. For example, if there is a user primarily belonging to domain A and start his session by accessing any file or page on domain C, let's say, so WebSphere will ask the user to authenticate with the master authentication server, and once the user is authenticated, his session will follow across all domains without re-authentication, and this session will definitely be transparent to the user. So this is the basic idea of single sign-on in the e-community method. So the basic process flow of the e-community single sign-on is that there will always be a single master authentication server, that is a WebSphere server, and all other additional WebSphere servers located in the home domain and remote domains. So the master authentication server can exist as a single instance of a WebSphere server or a set of WebSphere replicas located behind a load balancer, where the load balancer is identified as master authentication server. So all participating local and remote WebSphere servers need to be configured to use the home domain, that is master authentication server, for initial client authentication. So this is the hard requirement for servers in the home domain, and soft requirements for the servers in the remote domains. For example, some servers in remote domains can be configured to handle their own authentication. So these servers and the resources they protect can operate independently of the e-community, even if they are located in participating e-community domains. The e-community implementation is based on a vouch for token. Normally when a user requests a resource from a WebSphere server where a user has not established a valid session, the WebSphere server identifies the WebSphere server and requests verification from this vouch for server that the user has authenticated. So once the user is successfully logged into the system, logged into the e-community domains, as I said earlier, that master authentication server will build the credential and stores those credentials in the cache, and redirects, and it will redirect the request to the browser to the originally requested URL on the WebSphere with an encrypted vouch for token. So and that token would be decrypted at the WebSphere instance to its own user credentials, and then after the authentication there comes the authorization, which permits either the user has access to those resources or not. Another method for having the single sign-on in an enterprise with ISAM is the cross-domain single sign-on, and Security Access Manager cross-domain single sign-on provides a default mechanism for transferring user credentials between unique servers and domains. This implementation is a bit different from e-community single sign-on, as it does not have any master authentication server for authentication. This solution supports the goal of a scalable network architecture by allowing the integration of multiple secure domains. For example, a large corporate extranet can be set up with 2 or more unique domains, each with its own users and object space, and cross-domain single sign-on allows the movement of user between the domains with the single sign-on. When a user make a request to any resource located in another domain, the cross-domain single sign-on mechanism basically transfers an encrypted user identity token from the first domain to the second domain, and the identity information in this token indicates to the receiving domain that the user is successfully authenticated in the first domain. So the identity does not contain the password information, but then the receiving server uses this token to build credentials in its own cache for that user. In this way, the user is not forced to perform an additional login. And the process it has is like all the WebSphere servers participating in the cross-domain single sign-on must have the same machine times, and the time on the machine must be synchronized. Otherwise, the authentication servers will fail the authentication if the time difference between those servers are too large. For cross-domain single sign-on to function successfully, each participating WebSphere server must reveal its fully qualified host name to the other participating servers in the cross-domain single sign-on environment. So if any host does not include a domain, cross-domain single sign-on cannot enable and cannot be enabled, and an error message will be logged in the log file of WebSphere. So when setting up an cross-domain single sign-on environment, one must ensure that the machine-specific networking setup for each participating server is configured to identify the server with fully qualified domain host names. So and because some WebSphere configuration requires machine host names to be described as fully qualified host names, you must ensure that your system and network resolve machine names into fully qualified domain host names as well. For example, the FQDN allows for many host names, IP addresses per machine, and in this case of multiple WebSeal instances we are talking about. The vouch for token has valid credential information for that user. For the user's first request, the vouch for server is always the mask. The mask continues the mask continues to serve as the vouch for server for resources located in the home domain. So the another thing is the CDSSO process flow, that how does the authentication mechanism works in cross-domain single sign-on. So this is the process you can see as you on the screen. Any user who wants to participate in multi-domain must have a valid user account, and in the initial domain, and an identity that can be mapped into a valid account in each of those participating remote domains. So a user cannot invoke the cross-domain single sign-on functionality without initially authenticating to an initial secure domain, let's say domain A, that contains the user account information. The user makes a request to access the resource in domain B using a custom link on a web page located on server WebSeal A, let's say. The link constructed using a special cross-domain single sign-on management page expression. It would be like a / PKMS CDSSO destination URL followed with the destination URL. So when the request is processed by the WebSeal server in domain A, the WebSeal A server calls the SSO create module to build an authentication token that contains the user credential, including the security access manager identity, that is the short name, in the current domain, that is domain A, and all other additional user information and timestamp as well. So the token create module can obtain extended user attribute information that can be used by domain B during the user mapping process. And attribute information can come from two sources. First, there is the stanza in WebSeal configuration file called CDSSO token attributes. If it is checked for configuration and the second thing is the CDMF library, that is cross-domain mapping framework. WebSeal basically triple encrypts these tokens with the symmetric key generated by the CDSSO key generation utility, and this key file is shared and is specified in the configuration file of WebSeal. There is an stanza called CDSSO peers, and in both of the WebSeal servers. So we need to specify those keys and path of those key files in both of these configuration files of WebSeal servers. So this token contains a configurable timestamp that defines the lifetime of the token, and the timestamp when properly configured can prevent like replay attacks as well. So the token is placed in a redirected request to the destination server using the URL contained in the PKMS CDSSO link. So the SSO create module provides basically the argument with the name of the origin server, that is WebSeal A in our case. So that is the destination server, that the destination server WebSeal B accurately knows where the redirected request is coming from, without relying on the browser's referer header information. The WebSeal A server sends the redirect response for the resource on WebSeal B containing the encrypted token back to the browser, and then the WebSeal server, the WebSeal B server basically recognizes the request as one of the containing a CDSSO token based on the value of the CDSSO argument stanza entry of its WebSeal configuration file. Then the WebSeal server B decodes and validates the token as coming from the referring domain. This process is performed by the token consume authentication module. When the constructing the attribute list for new identity, the token consume module first processes the attribute according to the settings in the WebSeal configuration file. Then the module calls to the CDMF library, which basically performs the actual user mapping. The CDMF library passes the user's mapped identity and any extended attribute information back to the token consume module, and the token consume module passes the identity to the WebSeal server, which builds a credential. The WebSeal B authorization service then permits or denies the access to protected objects based on the user credential and the specific ACL or protected object policies permissions associated with the requested objects. Here is the small CDSSO configuration parameters to achieve cross-domain single sign-on. As you can see, to enable the WebSeal to generate CDSSO token, there is a parameter CDSSO create in config file. The file would be named as WebSeal D / or hyphen instance name .config. Then there's a CDSSO pair stanza that is configured, and it is to be used to generate keys and shared with all the participating servers in the CDSSO domain. You can also label the token under CDSSO argument parameter and define the life of the token. So this was all from the authentication mechanisms and the multi-domain single sign-on from IBM Security Access Manager. And the next thing that comes into action is, after authentication, it is authorization. Basically, let me tell you that authorization is a process of determining whether or not to grant access to a protected resource. When the user are first authenticated and they request access via WebSeal protected object path, this path determines that a specific resource that is being accessed. So ISAM evaluates policy for this resource and grants access to the resource if the user belongs to an authorized group or not. So access control can be managed with ISAM by identifying resources to be protected and then configuring policy to allow access to groups of users that require access to those resources. Your security policy should be defined this type of access information, or the security policy is implemented in ISAM using access control list ACLs and protected object policies POPs and groups. So the protected object space contains basically virtual representation of the resources in the domain. Some of the objects in the protected object space represent resources. Other objects in the object space are containers for the resources. So administrators can use container objects to create logical groups of resources. Objects like in the protected object space can be created, listed, copied, imported, exported, deleted, and etc. With the authorization, you will always have the ACL permission implemented in the ISAM. Access control list have the permissions for each group or users attached to them, and the requirements of individual users and applications are analyzed, which provides a list of required roles. And roles can be implemented at several levels of depending on whether the authorization is coarse-grained or fine-grained. And the minimum requirement is that the user needing a specific access, for example to the backend server, are grouped together. ACLs are created for the group. This is referred to as the level 1, which is called the coarse-grained access control, and level 2 is a finer-grained access control, can minimally be implemented with ACLs being attached to the specific URL paths. So group information can also be included in the HTTP headers for use by the backend application. And level 3 fine-grained access control is implemented by the backend application being integrated with the security solution. All the backend application can then define roles that are required, with Security Access Manager providing the means to assign them users or roles to the users. So there can be multiple authorization scenarios. You can design a graphical interface, as you can see in the figure 1. You can design a graphical interface to dynamically allow interface controls as active or inactive according to the results of the authorization set. As you can see that in figure 1, it illustrates that a request for a common gateway interface CGI transaction by a web application. The lowest level of authorization, as is illustrated in figure A, involves an all or nothing access control on the uniform resource locator. So this coarse-grained level of authorization determines whether only the client can run the CGI program or not. If access is allowed to the CGI application, no further control is available to resources manipulated by the CGI application. And as you can see in the figure B, access controls were set on resources that the CGI program manipulates. The web application is configured to use the authorization API, and the CGI program can call the authorization service to make authorization decisions on resources it manipulates based on the identity of the requesting client, basically. Other than authentication and authorization, there are several other features in ISAM. As you can see, a list of many features. HTTP transformation rules, which you can use to represent the change that you want to apply to the HTTP request and response as they pass through WebSeal. Customized login response, redirect fields, EAI extensions to support external authentication mechanism, single sign-off, which gives the option to sign off and terminate all sessions of a single user on a single click. Then there is the feature of session sharing between virtual host junctions, configurable junction precedence, PD admin and WPM enhancement, which gives you a much better and flexible option to administer ISAM, and policy server tracing to track the transparent behavior and operation of ISAM. You can create WebSeal clusters also to achieve redundancy across authentication server, and there is also improved EdgeX integration. Let's talk about one of those features in detail, a bit detail. The first one is the authentication failure that we talked about. To extend the scalability features to the backend server configuration, you can replicate the backend servers as well. In the case with replicated front-end servers, replicated backend servers must contain web spaces that are mirrored images of each other, basically. So WebSeal load balances across replicated servers using a least busy scheduling algorithm, and this algorithm directs each new request to the server with the fewest connections already in progress. Now, WebSeal also correctly fails over when a server is down and starts reusing the server after it has been restarted. So if the backend applications requires its state to be maintained over several pages, stateful junctions can be used to ensure that each session turns to the backend server, same backend server. The another feature is the support for EAI external users. Security Access Manager is basically provides external authentication interface that enables you to extend the authentication process for WebSeal. The external authentication interface allows an independent remote service to handle the authentication process for WebSeal. So the identity information returned by the external authentication interface service is used to generate user credentials. With ISAM 7.0 and above, you can set support for external users that does not exist or synchronize with ISAM registry. Though the condition is that the users should exist in the ISAM registry. And application owners need to specify the user IDs, group names, and attributes in external authentication response. When using the external authentication, the external authentication operation is performed to WebSeal by a custom application located on a remote junction server, and the design, methodology, and code for the custom authentication application is entirely the responsibility of application developer. There is another feature called session sharing between virtual hosts, and it is done in two different categories. Like one session would be maintained for all standard junction, and the one session would be maintained for all virtual host junctions. So WebSeal basically supports WebSeal virtual hosting, and through virtual host junctions, it can eliminate the limitations of URL filtering. You can use virtual host junctions to communicate with local or remote virtual hosts. So WebSeal will use the HTTP host header in client request to direct those requests to appropriate document spaces on junction servers or on the local computer. So domain cookies are definitely different from session cache because it can create conflicts. However, session cache can be shared with domain cookies on certain conditions, like the cookie is multi-valued, in indexed, should be working on the same WebSeal instance, and WebSeal and virtual host junctions are on the same domain as well. The another feature is single sign-off, that is the user exit. You can configure WebSeal to send HTTP request to any predefined application with the session when the session is terminated. The application that receives these requests can terminate any associated sessions that are located on junction servers, junction backend servers. When a session is ended, WebSeal deletes the session and the session that it manages. all of these would be deleted. So WebSeal cannot control sessions created and managed by the backend applications. So this situation results in backend server sessions remaining active after the corresponding WebSeal session is terminated, and it provides a mechanism to remove sessions on backend server when the session ends in WebSeal. To achieve single sign-off, WebSeal sends a request to configure single sign-off URIs whenever a WebSeal session is destroyed. Using the information provided in the request application on the backend servers can terminate the stale sessions. Definitely, Security Access Manager has also some scalability and availability features. When this product is used in an enterprise, the owners would definitely look for an architecture that has scalability and availability for ISAM as well. In creating and implementing an architecture of security and middleware servers for ISAM implementation, you can seriously consider the availability requirements. Like test and development servers can involve single server implementation, but however this approach is not practical for large production implementations with specific performance and availability requirements. So let's say, for example, does the architecture allow for horizontal scaling by adding security or middleware servers? So when ISAM session management server is used in the solution, availability requirements must be applied to the WebSphere as well. A common requirement is for no single point of failure, and this requirement is a good place to start. So other requirements might be related to response times to client web server users at specific server loading values. After the requirements are known and defined, an implementation architecture for ISAM can be created to satisfy those requirements. This process is required for all production implementation. So coming to the conclusion of this webinar, these are the solution benefits. Like it can provide discrete security services with the decreased vulnerabilities and improved maintenance, and minimizes security loads of application teams, and simultaneously providing the better services in terms of web application single sign-on, simplified registration approval process, and quick audit and reporting features as well. Here are some URLs. You can go to them and you can see all the details and references to this related to these products. And that's it from this webinar. If you have any questions, you can send us an inquiry email, and we will sure be able to reply you as soon as possible. Thank you all. Thank you for the attendance.
Okay, thank you, Mr. Awais Sheikh. Guys, right now is the time for our live Q&A session. I would like to point out all you guys towards your screen. If you can notice on the right hand side, there's a chat window open for you guys. We're taking inquiries and questions right through our GoToMeeting webinar process. So if you guys have any questions, you can give it to us live right now. If you have any queries for later, you can email us at marketing@royalcyber.com. Also, get free 40 hours consultancy. So if any of you companies are looking for a upgrade or a migration, do send us an email at marketing@royalcyber.com. Thank you and have a great day. Bye bye.